Okay, guys. So the next thing that's kind of important to know about is the heating and cooling curve. Okay. Now with this, we can see that we're starting off at a high temperature, and over time we're cooling down. So this is actually an example of a cooling curve. Okay. Now in this case, when we start off at a high temperature, okay, we're looking at how the phases of matter change over time and as energy is added. Okay, what is happening to things? Now, from point A to point B, you're going to have a gas. Okay, and the reason why this is because you're at that high temperature. The atoms are moving very quickly. Okay, now as the gases start to cool down, they will slowly begin to condense. Okay, and when they are completely condensed, okay, they turn into liquids. And as liquids continue to cool down, they start to freeze, and then they freeze and become a solid. Now, at this point, we would have gas and liquid. Okay, it's starting to condense. But at this point, we have reached where we only have liquids. And then same here, we're starting to have liquids and solids. Okay, so phase changes can exist two at a time unless you're at what we learned in the video before about at the triple point, which is a special point where the pressure and temperature are exactly right in order for you to see all three happen at the same time. Okay, now in a heating and cooling curve, your temperature is on the x-axis, or excuse me, on the y-axis, your time in minutes. Sometimes you might see this as energy in joules, okay, is going to be on our x-axis. And you need to be able to correctly draw and label this type of graph. Now it's very important to understand that on this line right here, which we can see is at 60 degrees Celsius, that is our boiling and condensing point. Okay, basically this is the temperature that liquids start to boil and the temperature where gases condense to become a liquid, which equally makes this point, which is at 20 degrees Celsius, our melting and freezing point. Okay, so you may be wondering, okay, well, if this is a cooling curve, what does a heating curve look like? And a heating curve looks very, very similar. Okay, but instead of going down, we start at the bottom and it heats up. And looks kind of like this, where we start off as solid, go to liquid, and become a gas. Okay, so gases are always at the top, solids at the bottom, liquids in the middle, and their appropriate phase changes in between. So we would go from solid to liquid, would be melting, okay, which is also called fusion. Okay, and as we go from a liquid to a gas, we have vaporization. Okay. Now there is math associated with this in terms of calculating the amount of energy it takes for these processes to happen. So look at the next video in order to go through the math of what actually happens when we move from one temperature to another, and how the energy is required to do that.